March 25, 2003. Somewhere south of Karbala, Iraq, beneath the fury of a blinding sandstorm that turned day into amber twilight, Major Qusay al-Hamdi, commander of the 14th Mechanized Brigade, 3rd Republican Guard Division, felt a confidence he had not experienced in weeks. Above his concealed position, sand churned at velocities exceeding 60 kilometers per hour, obscuring visibility to less than 50 meters. American aircraft, he believed, would be grounded. Their vaunted precision weapons useless. His tank column, dispersed beneath highway overpasses and camouflaged among date palm groves, would remain invisible until the storm passed. Then they would move south under darkness, reinforcing defensive positions around Baghdad. Intelligence briefings had been clear. American laser-guided munitions required clear sight lines, direct visual contact between aircraft and target. The sandstorm was nature's own air defense system, purchased without cost, delivered exactly when needed most. At exactly 1400 hours local time, Major al-Hamdi's world ended. A GBU-31 Joint Direct Attack munition, released from a B-1B Lancer flying at 28,000 feet and 15 miles distant, fell through the sandstorm with mechanical indifference. Its GPS-aided inertial navigation system had locked target coordinates transmitted from a joint surveillance target attack radar system aircraft orbiting beyond the storm's reach. The 2,000-pound bomb required no laser designation, no pilot's eyes on target, no break in the weather. It simply fell, adjusted its trajectory through moving tail fins, responding to satellite positioning data updated multiple times per second, and detonated within 3 meters of Major al-Hamdi's command tank. The explosion killed him instantly, along with his operations officer and 2 radio operators. Within 90 minutes, 11 more tanks in his brigade would be destroyed by GPS-guided bombs dropping through weather that Iraqi commanders had considered impenetrable. The Republican Guard's confidence in natural concealment died that afternoon beneath the Karbala sandstorm, executed by weapons that treated darkness and dust as irrelevant variables in a mathematical equation. Yet this technological humiliation had not emerged overnight. Soviet military doctrine, inherited and adapted by Iraq, had spent 5 decades preparing for war against the West. That doctrine assumed certain physical constants. Aircraft required visual contact to deliver accurate ordnance. Clouds, smoke, darkness, and weather degraded bombing accuracy to levels that made massed armor formations survivable. Anti-aircraft systems forced enemy aircraft to choose between high-altitude safety with poor accuracy or low-altitude accuracy with lethal exposure to ground fire. Throughout the Cold War, from the plains of Central Europe to the deserts of Syria, Soviet strategists built their operational concepts around these assumptions. They were not stupid assumptions. They were validated by every conflict from Korea through Vietnam. American bombs, however sophisticated their delivery aircraft, still relied fundamentally on someone or something seeing the target. Break that visual chain, Soviet doctrine insisted, and precision collapses into the random scatter patterns that had characterized aerial bombardment since 1918. The arrogance was not merely tactical. It was institutional, embedded in decades of military education, equipment procurement, and strategic planning. Marshal Nikolai Agarkov, chief of the Soviet General Staff from 1977 to 1984, had studied American precision weapon development with clinical attention. His classified assessments, portions of which were declassified by CIA in 2000, acknowledged that the United States was developing guided munitions superior to Soviet equivalents. But Agarkov's analysis, like that of his contemporaries, focused primarily on laser-guided bombs and anti-tank missiles. These weapons, Soviet intelligence correctly noted, required terminal guidance. A laser designator had to paint the target, an infrared seeker had to lock onto heat signatures, an electro-optical sensor had to acquire visual confirmation. Each guidance method possessed exploitable vulnerabilities. Laser designators could be obscured by smoke or defeated by rapid maneuver. Infrared seekers struggled in conditions of thermal similarity or when decoys presented alternative heat sources. Electro-optical guidance failed in fog, darkness, or heavy precipitation. Soviet defensive doctrine therefore emphasized generating exactly these conditions. Smoke generators became standard equipment for armored formations. Commanders were trained to move under weather cover. Air defense systems were designed to force Western aircraft above the weather, beyond the effective range of visual targeting systems. The flaw in this reasoning was fundamental. Soviet strategists assumed that American precision weapons would continue to depend on terminal guidance systems affected by atmospheric conditions. They were preparing to fight the war of 1982, not 2003. The conceptual leap they failed to anticipate was the weaponization of space itself. the transformation of navigation satellites from passive positioning tools into active components of a strike network that rendered weather and darkness operationally meaningless. When global positioning system satellites began transmitting precise timing signals from medium Earth orbit, Soviet intelligence tracked the deployment with concern, but without full comprehension of the strategic revolution underway. GPS appeared initially as a navigation system, valuable for maritime and aviation uses, but not fundamentally different from terrestrial radio navigation networks. The possibility that these satellites could guide bombs to within meters of designated coordinates, in any weather at any hour from aircraft flying beyond visual or radar range, represented a paradigm shift that Soviet doctrine was institutionally unprepared to process. By the time Saddam Hussein's military planners inherited Soviet equipment and doctrine in the 1990s, the technological gap had widened to a chasm. Iraqi officers, many trained in Soviet academies, absorbed the same assumptions about weather as defensive advantage and visual requirements for precision strike. These assumptions were not challenged during the 1991 Gulf War because weather during Desert Storm remained largely clear, and because the proportion of precision-guided munitions in the American inventory was still relatively small. Only 10% of participating U.S. strike aircraft in 1991 were capable of delivering precision-guided munitions. The war ended too quickly for Iraqi forces to systematically test whether adverse weather would degrade American strike effectiveness. Iraqi military analyses after 1991 therefore concluded that future conflicts should be planned around weather windows, urban concealment, and rapid maneuver under conditions that would break the targeting chain between American sensors and shooters. The innovation that destroyed these calculations had emerged from the defense corridors of Southern California and the aerospace research facilities scattered across the American Southwest. In late 1991, as Iraqi forces withdrew from Kuwait and as the Soviet Union entered its final months of existence, the United States Air Force and Navy formulated joint requirements for an adverse weather precision-guided munition. The program name itself announced its purpose. American military planners analyzing the 1991 Gulf War had identified a critical vulnerability. When smoke, dust, fog, or cloud cover obscured target areas, laser-guided bomb attacks were frequently aborted. Pilots returned to base with full ordnance loads because their targeting pods could not maintain laser lock through atmospheric interference. This was operationally unacceptable. The enemy had discovered a simple countermeasure to American technological advantage. Set fires, generate smoke, wait for bad weather, and precision strike capacity degraded to levels comparable with unguided ordnance. The solution required abandoning the assumption that bombs needed to see their targets. Instead of terminal guidance dependent on atmospheric transparency, American engineers would use space-based navigation to guide weapons from release to impact. GPS satellites, orbiting at altitudes of approximately 20,000 kilometers, transmitted precisely timed radio signals that allowed receivers to calculate their position through triangulation. The system was already being used for navigation by ships, aircraft, and ground vehicles. The conceptual breakthrough was integrating GPS receivers with inertial navigation systems inside the tail section of conventional bombs, transforming unguided iron weapons into precision-guided munitions that required no human or sensor input after release. An aircraft could drop the weapon from altitude in darkness through weather, and the bomb would autonomously navigate to pre-programmed coordinates with accuracy measured in meters rather than hundreds of meters. The technical challenges were substantial but not insurmountable. In early 1992, the Air Force initiated a rapid response demonstration program at Eglin Air Force Base. Engineers from Honeywell, Interstate Electronics Corporation, Sverdrup Technology, and General Dynamics were contracted to prove feasibility within 12 months. They fitted a GBU-15 guided bomb with an experimental GPS-aided inertial navigation package. On February 10, 1993, an F-16 released the modified weapon against a target 27 kilometers downrange. The bomb, guided solely by GPS and inertial sensors, struck within 11 meters of the aim point. 5 additional tests in varying weather conditions, altitudes, and ranges confirmed the concept. GPS guidance worked. It worked in conditions that defeated laser designation. It worked at standoff ranges that minimized aircraft exposure to air defenses. It worked with accuracy sufficient to strike point targets rather than area targets. The demonstration prompted immediate transition to full development. In April 1994, development contracts were awarded to McDonnell Douglas and Martin Marietta. Both companies designed tail kits containing GPS receivers, inertial measurement units, control electronics, and movable tail fins. The kits would be strapped onto existing bomb bodies, the Mk-83 1,000-pound bomb, the Mk-84 2,000-pound bomb, and later the Mk-82 500-pound bomb. This approach was economically and logistically brilliant. The United States military possessed vast stockpiles of unguided bombs manufactured over decades. Rather than scrapping these weapons and building entirely new guided munitions from scratch, JDAM transformed existing inventory into precision weapons at a fraction of the cost. Each guidance kit cost approximately $21,000, compared to hundreds of thousands for equivalent laser-guided bombs or cruise missiles. After wind tunnel tests and competitive evaluation, McDonnell Douglas was selected in October 1995 as prime contractor. Flight testing began in 1996. Low-rate initial production commenced in April 1997. By December 1998, JDAM achieved initial operational capability on the B-52H bomber. The technical specifications revealed capabilities that Soviet defensive doctrine had no framework to counter. Using full GPS-aided inertial navigation guidance, JDAM accuracy was officially specified at 13 meters circular error probable, meaning that 50% of weapons would impact within 13 meters of the aim point. Actual combat performance exceeded specifications. The average miss distance in Operation Iraqi Freedom would be approximately the length of the bomb itself, between 3 and 4 meters. When GPS signals were unavailable due to jamming or satellite geometry, the weapon could navigate using inertial guidance alone, with accuracy degrading to approximately 30 meters, still sufficient for many tactical applications. From typical operating altitudes, JDAM possessed a standoff range of 8 to 24 kilometers, allowing aircraft to release weapons outside the engagement envelope of many air defense systems. The weapon was completely autonomous after release. The pilot received no feedback, required no terminal guidance input, and could immediately maneuver away from the target area. Multiple JDAMs could be programmed with different target coordinates and released simultaneously, allowing a single aircraft to strike numerous targets on one pass. The strategic implications were staggering but initially underappreciated. JDAM entered operational service just as the Cold War threat environment was dissolving. The weapon was designed to strike Soviet armor columns massing in the Fulda Gap under Central European winter cloud cover. Instead, its first combat deployment occurred in June 1999 during Operation Allied Force against Yugoslavia. 6 B-1B bombers flew missions over the Balkans, dropping JDAM through weather conditions that had grounded or limited other strike assets. The weapons performed exactly as designed, striking targets obscured by cloud cover and delivering more than 20% of total coalition ordnance, while flying fewer than 2% of combat sorties. Yet quantities remained limited, and JDAM was certified on only a handful of aircraft types. The weapon's true revolution would emerge in Afghanistan in 2001 and Iraq in 2003, when JDAM became the standard munition across nearly the entire American strike aircraft fleet. Afghan Taliban and al-Qaeda forces encountered JDAM first. Northern Alliance fighters, allied with American Special Operations teams, watched in astonishment as precision strikes demolished Taliban positions at night, through mountain weather, with accuracy that seemed technologically impossible to combatants equipped with Soviet-era weapons and doctrine. General Charles Wald, the air component commander during the initial phase of Operation Enduring Freedom, observed that Afghan allies were shocked by the concept of bombs arriving from aircraft flying so high they were neither visible nor audible, striking precisely designated targets in darkness or through weather, often within minutes of target coordinates being transmitted. The psychological impact was immediate. Taliban commanders discovered that darkness no longer provided concealment, that weather no longer grounded American aircraft, that movement attracted destruction even when no aircraft were visible overhead. The technological gap was so vast that it seemed closer to magic than engineering. Yet JDAM employment in Afghanistan was limited by the relatively small number of targets and the rapid collapse of Taliban conventional resistance. Iraq would provide a far more comprehensive demonstration. By March 2003, JDAM had been integrated onto virtually every American combat aircraft. B-52 bombers could carry up to 24 JDAMs per sortie. B-1B bombers with their expanded weapons capacity could carry 80. B-2 stealth bombers combining low observable technology with GPS-guided munitions could penetrate defended airspace and strike 80 separate targets on a single mission without ever being detected by enemy air defenses. Fighter aircraft, including F-15E Strike Eagles, F-16 Fighting Falcons, F-A-18 Hornets, and the newly operational F-22 Raptors all carried multiple JDAMs. Navy aircraft launching from carriers in the Persian Gulf and Red Sea were similarly equipped. The total JDAM inventory had grown from a few hundred weapons in 1999 to tens of thousands in 2003. Production facilities were operating at maximum capacity, manufacturing guidance kits at rates exceeding initial program projections by orders of magnitude. Iraqi military planners analyzing American capabilities understood that precision-guided munitions would be used extensively. They had observed Kosovo, Afghanistan, and the steady integration of GPS weapons into American doctrine. Yet they retained faith in countermeasures derived from Soviet defensive theory. Disperse forces to minimize target concentration. Position key assets near mosques, hospitals, and civilian infrastructure to exploit American rules of engagement. Use urban terrain where collateral damage concerns would limit strike options. Generate smoke and dust to obscure targeting. Move at night and during weather. Above all, avoid concentrating forces in open terrain under clear skies where American sensors and precision weapons enjoyed maximum advantage. These were rational adaptations based on decades of military experience. They failed catastrophically because they assumed American precision weapons retained the limitations of previous generations. The sandstorm that struck southern Iraq on March 24 and 25, 2003 appeared to validate Iraqi defensive assumptions. Visibility collapsed. Ground operations slowed. The 3rd Infantry Division, advancing rapidly toward Baghdad, found itself isolated on the far side of the Euphrates River, surrounded by Iraqi forces that believed the weather provided cover for counterattack. Republican Guard divisions began moving south from defensive positions around Baghdad and Karbala, intending to engage American ground forces under conditions that would negate American air superiority. Initial intelligence reports struggled to confirm enemy movements through the storm. Then Joint SDARS radar aircraft, flying above the weather at altitude, detected vehicle columns moving across the desert. The E-8C Joint SDARS platform, equipped with synthetic aperture radar and moving target indicator systems, could track ground vehicles regardless of weather, darkness, or camouflage. As Iraqi units moved, JSDARS operators generated GPS coordinates for each detected vehicle concentration, and transmitted that data to strike aircraft holding in sectors surrounding the battlefield. What followed was systematic destruction on a scale that shattered Iraqi operational capability. Anytime an enemy unit moved, it was acquired by JSDARS. Its coordinates were generated and transmitted, and precision-guided munitions were delivered through the storm within minutes. B-1B bombers, each carrying dozens of JDAMs, loitered at altitude in holding patterns. When target coordinates arrived, weapons were programmed and released. The bombs fell through the sandstorm, completely unaffected by wind, dust, or darkness. GPS satellites continued transmitting navigation signals. Inertial guidance systems continued calculating trajectory corrections. Movable tail fins continued adjusting the weapon's flight path. Iraqi tank crews, confident they were concealed by nature's fury, died without ever seeing the aircraft that killed them. Some commanders did not even hear the bombs falling, the sound of detonation and the sensation of death arriving simultaneously. Terminal air controllers embedded with the 3rd Infantry Division called in hundreds of precision strikes during the sandstorm. Iraqi forces attempting to exploit weather cover discovered instead that weather had become meaningless. Republican Guard units moving south from Baghdad were detected, tracked, and destroyed while still kilometers from American ground positions. The sandstorm that Iraqi commanders expected to provide operational advantage instead became an execution chamber. American ground forces, equipped with GPS navigation and night vision systems, maintained situational awareness and continued advancing. Iraqi forces, operating with map and compass, struggled to navigate and coordinate while being systematically obliterated by weapons they could neither see nor counter. The psychological impact was immediate and devastating. Interrogation reports and captured documents from Iraqi officers revealed profound shock at the technological disparity. Officers described hearing explosions but seeing no aircraft. They reported losing vehicles to strikes that arrived without warning, without visible attackers, at times, and in weather conditions they believed made air operations impossible. Communications intercepts recorded Iraqi commanders requesting orders, reporting losses, and expressing confusion about how American forces were locating and striking concealed positions. The concept that satellites orbiting in space could guide bombs to within meters of their coordinates was beyond the technical comprehension of many Iraqi field officers. Some believed they were being targeted by informants on the ground. Others suspected new forms of surveillance technology but lacked any doctrinal framework for responding. The most operationally damaging effect was the collapse of confidence in concealment. If darkness, weather, and dispersion no longer provided protection, then every position was vulnerable at every moment. That realization destroyed unit cohesion faster than the weapons themselves. By late March, Iraqi Republican Guard divisions south of Baghdad had been rendered combat ineffective without ever engaging American ground forces in decisive battle. The Medina Division, positioned to defend the approaches to Baghdad, was struck repeatedly by JDAM attacks coordinated with JSDARS surveillance. The Hammurabi Division, attempting to reposition under cover of darkness and weather, suffered similar devastation. Regular army units, observing the destruction of elite formations by invisible attackers, began surrendering or deserting en masse. The pace of the American ground advance accelerated beyond even optimistic planning projections. Iraqi defensive positions, painstakingly prepared over months, were bypassed or destroyed from the air before ground forces arrived. Urban strongpoints that Iraqi planners believed would force costly close combat were struck with precision that allowed American forces to isolate and reduce resistance building by building. Throughout Operation Iraqi Freedom, coalition aircraft flew approximately 20,700 sorties and struck approximately 19,900 aim points, delivering 29,200 munitions. Of these, 68% were precision-guided, a proportion unprecedented in the history of aerial warfare. JDAM alone accounted for 22.4% of total munitions expended, approximately 6,500 weapons. The transformation from Desert Storm was total. In 1991, only 10% of strike aircraft could deliver precision weapons. In 2003, 90% could. In 1991, one aircraft struck one target per mission. In 2003, one aircraft could strike dozens of targets simultaneously. The operational tempo, destructive efficiency, and psychological dominance achieved through GPS-guided munitions fundamentally altered the character of conventional warfare. Soviet military observers, analyzing American operations in Iraq, recognized immediately that their defensive doctrine had been rendered obsolete. Russian military journals published assessments describing American capabilities as a theater strategic offensive conducted with conventional weapons. The term used was reconnaissance strike complex, referring to the integration of space-based navigation, airborne surveillance, network command systems, and precision weapons into a system that located and destroyed targets with industrial efficiency. Soviet defensive theory, built around forcing enemy aircraft into disadvantageous choices between altitude and accuracy, collapsed when American weapons achieved precision from high altitude through any weather. Soviet concealment doctrine, emphasizing camouflage and weather exploitation, failed when American sensors operated through atmospheric conditions and guidance systems ignored visual obscuration. Soviet maneuver doctrine, relying on rapid repositioning to avoid targeting, was defeated when movement itself became the triggering signature for GPS-coordinated strikes. The cost differential was equally devastating from a strategic perspective. Each JDAM guidance kit cost approximately $21,000. The satellite navigation infrastructure was already paid for and operational, supporting not just military but civilian applications worldwide. The targeting network, integrating JSDARS radar aircraft, reconnaissance satellites, and special operations ground teams, represented significant investment but served multiple mission sets. Against this, adversaries needed to invest in air defense systems costing millions per battery, provide electronic warfare capabilities to attempt GPS jamming, develop operational security procedures to limit electromagnetic signatures, and accept that none of these countermeasures would restore parity. Even successful GPS jamming degraded JDAM accuracy only to 30 meters, still sufficient for many tactical applications, and jamming systems themselves became high-priority targets once activated and located. If you appreciate discovering the hidden revolutions in military technology that enemies dismissed until too late, consider subscribing to Classified Warfare for future examinations of innovations that changed warfare forever. The extended-range variants began development soon after the initial JDAM success. Australia's Defence Science and Technology Organisation partnered with Boeing to develop wing kits for 500-pound JDAM weapons, tripling their range to approximately 80 kilometers when released from high altitude. This transformed JDAM from a direct attack weapon into a standoff glide bomb, allowing aircraft to strike targets from beyond the engagement range of advanced surface-to-air missile systems. South Korean aerospace companies developed similar wing kits for 2,000-pound JDAMs, creating weapons that combined long range with bunker-penetrating capability. The U.S. military adopted extended-range JDAM for specialized applications, including mine delivery and maritime strike. Each iteration expanded the mission envelope, making more targets accessible while reducing risk to strike aircraft. The laser JDAM variant addressed the one significant limitation of GPS guidance, the inability to strike moving targets. Standard JDAM navigated to pre-programmed coordinates, ideal for fixed targets but useless against vehicles or ships that relocated between weapon release and impact. In 2007, Boeing received production contracts for laser seeker kits that could be added to JDAM guidance sections. The resulting weapon, designated LJDAM, combined GPS navigation to the target area with terminal laser homing for the final seconds of flight. This allowed strike aircraft to engage mobile targets with the same all-weather capability and accuracy as fixed targets. Tank columns, moving missile launchers, and naval vessels could now be struck under conditions that defeated pure laser-guided weapons. The integration of GPS and laser guidance created a weapon that operated in any weather but could adjust to target movement in real time. Iraqi commanders discovered during the war that there was no sanctuary remaining on the modern battlefield. Underground bunkers were struck by 2,000-pound JDAM weapons fitted with BLU-109 penetrating warheads, munitions specifically designed to punch through reinforced concrete before detonating inside protected structures. Leadership facilities disguised as civilian buildings were hit with such precision that adjacent structures suffered minimal damage. Mobile command posts, believing that constant relocation would prevent targeting, were tracked by reconnaissance assets and destroyed within hours of stopping. Artillery batteries that fired and attempted to displace before counter-battery response arrived found that GPS coordinate D strikes could be delivered faster than they could move. The systematic collapse of Iraqi command and control, logistics, and combat capability proceeded with a speed that invalidated decades of doctrine built around fighting and surviving modern conventional war. The economic implications extended far beyond individual weapon costs. American aircraft, launching from bases in Kuwait, Qatar, and aircraft carriers in the Gulf, could strike targets throughout Iraq without needing forward airfields close to combat zones. This reduced infrastructure requirements, minimized force protection concerns, and allowed concentration of support facilities at secure locations. The accuracy of GPS weapons meant that planners could assign fewer aircraft and munitions per target, reducing sortie requirements and logistical burden. A target that might have required multiple aircraft dropping dozens of unguided bombs in previous conflicts could now be destroyed by a single aircraft dropping one or two JDAMs. This force multiplication effect allowed smaller numbers of aircraft to achieve effects previously requiring massive bomber formations. The Iraqi experience was studied intensively by military establishments worldwide, particularly by nations equipped with Soviet-era weapons and doctrine. Chinese military analysts published extensive assessments of American precision strike capabilities, concluding that GPS weapons represented a fundamental shift in the conventional military balance. Iranian strategic planners, observing the destruction of Iraqi forces equipped with weapons similar to Iran's own inventory, accelerated programs in ballistic missiles, asymmetric warfare, and proxy force development, calculating that conventional defense against American air power was no longer viable. North Korean military doctrine, already emphasizing concealment and dispersion, incorporated lessons about the futility of weather-dependent defense, but struggled with the economic impossibility of developing equivalent capabilities. Russia, inheritor of Soviet military industry and doctrine, initiated programs to develop GPS equivalents and precision-guided munitions, but faced the challenge that comprehensive modernization would require resources exceeding available defense budgets. For the United States, JDAM became the standard air-to-ground weapon across all services and platforms. Production continued for years beyond initial program projections, eventually exceeding 250,000 guidance kits. The weapons were exported to allied nations, with variants developed for specific customer requirements. Integration efforts expanded to include aircraft types not initially planned for JDAM capability, including unmanned aerial vehicles. The success of the program validated the concept of converting existing weapons through add-on guidance kits rather than developing entirely new munitions, a model that influenced subsequent programs across multiple weapon categories. The GPS satellite constellation that enabled JDAM was upgraded and expanded, ensuring that precision navigation signals would be available globally for decades. The doctrine surrounding JDAM employment evolved continuously through combat experience. Initial concepts emphasized striking fixed targets in all weather. Afghanistan demonstrated effectiveness against dispersed, irregular forces when combined with special operations targeting. Iraq validated capability against conventional military formations under the most challenging environmental conditions. Subsequent operations in Syria, Libya, Yemen, and across Africa refined tactics for urban warfare, counterterrorism strikes, and close air support in proximity to friendly forces. Each operational environment revealed additional capabilities or limitations, driving software updates, training modifications, and tactical procedure development. The weapon system that began as an adverse weather precision munition became the foundation of American air-to-ground strike capability across the full spectrum of conflict. The countermeasures developed by adversaries proved largely ineffective. GPS jamming systems were deployed by Iraqi forces during Operation Iraqi Freedom, generating interference intended to prevent JDAM weapons from receiving satellite navigation signals. Analysis of combat data showed minimal degradation in weapon performance. Jammers were quickly located and destroyed, often by the GPS-guided weapons they attempted to defeat. When GPS signals were denied, JDAM inertial navigation provided sufficient accuracy for most tactical applications, and the duration of jamming effectiveness was measured in minutes before the transmitter became a priority target. More sophisticated electronic warfare approaches, including GPS spoofing attempts to feed false position data to weapons, required technical capabilities beyond most adversaries and prompted development of anti-spoofing modules that authenticated satellite signals. Physical countermeasures fared no better. Hardening of targets through additional concrete and soil cover required resources and time that most adversaries could not afford at scale. Mobile targets attempting to avoid strikes through constant movement found that reconnaissance systems could track them continuously, and that weapon delivery timelines had compressed to minutes rather than hours. Urban concealment, placing military targets in proximity to civilian infrastructure, raised legal and political complications for American targeting decisions, but did not prevent strikes when commanders judged military necessity outweighed collateral damage risks. The precision of GPS weapons actually enabled strikes in urban environments that would have been impossible with unguided munitions, allowing destruction of individual buildings while leaving adjacent structures intact. The strategic lesson absorbed by military establishments worldwide was unambiguous. Space had become the ultimate high ground, and the nation that controlled orbital infrastructure for navigation, surveillance, and communications possessed decisive advantage in conventional warfare. The weaponization of GPS, transforming navigation satellites into components of a strike network, demonstrated that future conflicts would be won or lost based on access to space-based capabilities. Nations without independent satellite navigation systems would be dependent on American GPS or would need to develop alternatives. China accelerated deployment of its Beidou navigation constellation. Russia expanded its GLONASS system. The European Union invested in Galileo. Each recognized that strategic autonomy in the 21st century required independent access to precision navigation from space. For Iraqi forces in 2003, these strategic calculations were irrelevant. They faced the immediate tactical reality of technological inferiority so complete that resistance was operationally futile. Tank crews who had trained for years in Soviet-style armored warfare found their vehicles destroyed by weapons released from aircraft they never saw, guided by satellites they could not reach, coordinated by surveillance systems they could not detect. Infantry units that dispersed in camouflaged positions according to doctrine were struck with precision that suggested perfect intelligence penetration, when in reality they were being tracked by synthetic aperture radar mapping their fighting positions from above weather and darkness. Artillery batteries that attempted to employ shoot-and-scoot tactics, firing and displacing rapidly to avoid counter-battery fire, were destroyed in place by GPS-coordinated strikes delivered faster than crews could reload and move. The collapse of Iraqi conventional military resistance was not primarily a failure of will or courage. It was the inevitable result of fighting with mid-20th century doctrine and weapons against an adversary that had fundamentally transcended the limitations of atmospheric warfare. The final Iraqi recognition of JDAM's impact came not from military leadership but from the dictator himself. Intelligence intercepts and subsequent interrogation reports indicated that Saddam Hussein, in the final weeks before the fall of Baghdad, expressed shock at the speed of military collapse. He had expected the Republican Guard to fight for weeks, bleeding American forces in urban combat that would generate casualties sufficient to erode domestic political support for the war. Instead, those elite formations were destroyed from the air before they could meaningfully engage. He had expected weather and urban terrain to provide his forces with tactical advantages that would offset American technological superiority. Instead, those factors proved irrelevant against weapons that navigated by space-based signals immune to atmospheric conditions. The strategic miscalculation was total. Iraqi planning had prepared for a version of warfare that American innovation had rendered obsolete. The human cost of this technological revolution was asymmetric beyond any previous conflict. American combat deaths during major combat operations in Iraq numbered 139. Iraqi military deaths were estimated between 7,000 and 10,000, though precise figures remain disputed. The disparity reflected not just JDAM but the entire integrated system of space-based navigation, airborne surveillance, network command, and precision weapons. American forces located, targeted, and destroyed Iraqi units while suffering minimal casualties in return. The force ratio required to achieve battlefield objectives collapsed from historical norms. Where previous doctrine might have required 3-to-1 or higher numerical superiority for offensive operations, American forces advanced successfully while outnumbered in theater because their ability to locate and destroy enemy forces from standoff range negated traditional calculations of combat power. The implications extended beyond Iraq to every potential adversary of the United States. The message delivered by JDAM was strategic and unambiguous. Investment in conventional military forces built around Soviet-era doctrine and equipment was futile. Air defense systems, armored formations, artillery concentrations, and dispersed infantry would be located by American surveillance networks and destroyed by precision weapons before they could achieve operational effects. Weather would not protect them, darkness would not conceal them, urban terrain would not shelter them. The only viable responses were asymmetric approaches that avoided direct military confrontation, development of equivalent space-based capabilities requiring decades and hundreds of billions in investment, or acquisition of weapons systems that could threaten American space infrastructure itself. Most adversaries lacked resources for the second option and were deterred from the third by the certain knowledge that attacks on American satellites would be treated as acts of war. They defaulted to the first option, emphasizing irregular warfare, proxy forces, and terrorism precisely because conventional military competition had become economically and technologically impossible. The GPS-guided JDAM represented more than a weapons system. It embodied a revolution in warfare as significant as the introduction of gunpowder, aircraft, or nuclear weapons. For the first time in history, military forces could strike any point on Earth's surface, with precision measured in meters, in any weather at any hour from standoff ranges beyond the reach of most defensive systems. The enabling technology was space-based navigation, a dual-use system serving civilian and military applications simultaneously, maintained by a satellite constellation costing billions to develop but providing capabilities that no terrestrial system could match. Adversaries who dismissed GPS as merely a navigation aid discovered too late that it was the foundation of American conventional military dominance. The Iraqi officer corps, trained in Soviet academies and equipped with Soviet weapons, learned this lesson in blood and wreckage across the deserts south of Baghdad. They learned it when their tanks were destroyed by bombs falling through sandstorms. They learned it when their bunkers were penetrated by weapons that struck within meters of aim points, despite being released from aircraft flying beyond visual range. They learned it when their dispersed formations were tracked by radar and destroyed individually with weapons that cost less than the vehicles they obliterated. They learned it when darkness and weather, the traditional allies of defending forces throughout military history, became meaningless variables in an equation where only GPS coordinates mattered. Most importantly, they learned it too late, in the final moments before 2,000-pound warheads detonated inside their command posts and fighting positions. Join us here at Classified Warfare as we continue to uncover the technologies and operations that redefine the balance of power, where adversaries discovered that underestimating American innovation carried consequences measured in destroyed divisions and collapsed strategies. The weaponization of space through GPS-guided munitions proved a truth that Iraqi commanders understood only in their final hours. Once the United States fixes your coordinates, physics and mathematics have already decided the outcome. The weapon is already falling, your confidence was already misplaced, the war was already over, you simply did not know it yet. The sandstorm that seemed like salvation was merely the weather through which your destruction would arrive, indifferent and inevitable, guided by satellites you could not see and calculating trajectories you could not predict, executing an outcome that your doctrine insisted was impossible right up until the moment of detonation. That moment, repeated thousands of times across Iraq in 2003, marked the end of one era in warfare and the beginning of another, where the high ground is orbital, the targeting system is space-based, and enemies who believed in the protection of weather and darkness discovered that the United States had weaponized geometry itself.